Hello, my name is Kelsey Connor, and I am going to be presenting a drug screencast today on fentanyl. We are going to be exploring its background, the history of its development, forensic testing, its detectability, and the dangers for both everyday citizens and law enforcement. So, fentanyl is a part of the opioid family. It was first discovered and synthesized by a man named Paul Janssen in 1960 as what he said, searched for the most powerful narcotic possible. It is 50 to 100 times more powerful than morphine, which is also a part of the opioid family. So to give you reference, morphine is used in more common procedures for pain control. It's a lot more strong than over-the-counter painkillers such as ibuprofen and Tylenol. It is prescription only and usually for use in hospitals when someone has undergone extreme pain. But fentanyl is 50 to 100 times more powerful. It can be used legally or illegally. So legally, it is prescribed, like I said, in hospitals. It can be prescribed in the form of patches that people attach to their body. It can be prescribed in the form of pills, which are like lozenges that people suck on. It can also be prescribed in the form of shots. So people can receive shots of fentanyl. This image up here in the right corner is a picture of the injection for IV use of the fentanyl citrate. So basically, it can be injected just like any other medication, just like morphine, anything else within a hospital. However, like I said, it is also used illegally. It is known as a street drug. It is created in labs, and it is usually distributed in the form of powder or pills, which are they're counterfeit lozenges, like I was talking about, that look like the legitimate prescription, but they're not. They are actually just street drugs. And what's scary about it is that they are often mixed with other illegal drugs, such as heroin. Heroin is also a member of the opioid family, but when citizens are buying these street drugs, it's very common that they'll be mixed together and they can be absolutely lethal. It is incredibly dangerous, and as a whole, there is an opioid crisis, and fentanyl is definitely a part of that. So, opioids are pain relieving by depressing the central nervous system. Essentially, that means that fentanyl binds to the body's opioid receptors, which are found in the areas of the brain that control one's pain and their emotions as well. So, what this does when it binds to these opioid receptors, it makes the user easily addicted to this drug, and this causes them to become dependent and only able to feel pleasure and satisfaction when they're using the drug, while simultaneously becoming desensitized to it. These are also what are known as narcotics or analgesics. And like I mentioned, they are used legally in hospitals, and most typically they'll be used by doctors that are working with chronic illness, chronic pain, patients that are dealing with terminal cancer, that are nearing the end of their journey. It's a medication that can keep one comfortable and out of pain because, like I said, it binds to the body's opioid receptors, which control pain. So it can be useful in these situations where life-saving isn't necessarily an option, and it's mainly about making one go comfortably. It can be used in that way. But like I said, it is also a part of the opioid family, which is an incredibly addictive and harmful substance when used illegally or purchased on the street. It can be detected in quite a few different ways, just like the primary ways that drugs in general are detected through color tests, through gas chromatography and mass spectrometry. Um, So for the preliminary screening, the color test is just a way where you add reagents to the presence of the opioid, or you add reagents to what could be an unknown chemical in order to detect the chemical. So in this case, the reagent Marquise reacts with the presence of most opioids like fentanyl by turning purple. So that's why it's called a color test, because you add the reagent to the chemical and the color that results identifies the chemical that we're working with. However, like I said, this is preliminary. It is not supposed to be used for any confirmatory purpose. It is not supposed to be used to come to draw any major conclusions. Like I said, this is just for preliminary use, and it helps narrow down what forensic toxicologists could be working with. Now, I mentioned gas chromatography and mass spectrometry. That is just a process that we can shorten by calling GCMS. And GCMS is an analytical technique that is used in the forensic examination of drug chemistry to determine the percentage of chemical compounds. So during the gas chromatography phase, it separates a sample into its individual chemical components. So by moving the chemicals, it uses a carrier gas to move the chemicals through a column. And once it emerges at the end of the column, it is separated into its own individual chemical components, which helps identify what these chemical components are. And the mass spectrometry portion of it is used to produce the spectrum. So the spectrum of each of the individual chemical components within that sample. And there's a quote from the National Forensic Science Technology Center that sums it up by saying, after passing through the GC column, the molecules are blasted with electrons at 70 electron volts, which cause them to break into unique fragments that turn into positively charged particles called cations. End quote. Then, after this whole process, based on their mass, they are filtered and detected to be sent to a computer, which carries out the process of identifying the ions as their chemical components using a database which compares them and identifies them. So I've got a picture here of the GCMS little machine, and what happens is these chemicals are injected using the carrier gas, and when they reach the end of their when they emerge, they reach the end of the GC process. They are separated. They are easier to identify, and then the mass spectrometry uses the mass of each chemical to determine how much is present in a sample, and it helps to identify just how much is available, how much was in the system, how much was present. And fentanyl can be detected in urine and in blood. It can also be detected in serum and plasma, but it has a short elimination half-life. In other words, it metabolizes quickly, so its detectability is not great for forensic toxicologists just because it doesn't last very long in urine. It can also be detected in the hair up to 5 months after use. So, as I've discussed, fentanyl is a very dangerous drug, especially for the general public, for street use, for anything not prescribed by someone with the licensing to prescribe such a drug. It is very dangerous. And for example, law enforcement has to be very careful. If they find it on a scene and they use all the proper precautions, such as using gloves to put it in a little baggie and preserve the evidence, they have to be careful to not press the air out of that bag too forcefully, because um, they can end up injecting it, or inhaling it, I mean. So, and it is potent in these small amounts. So if an officer were to handle it improperly, they can inhale the drug, and if it's too much, it can be deadly. However, like I said, it causes incredible dependency and addiction, so they have to be very careful when handling it. Because when you let the air out of a bag, it will cause an interaction with the drug if it is close to your face, if it is let out haphazardly. There are a lot of ways that this drug can be injected into one's system, if you will. And so law enforcement must take incredibly careful precaution by ensuring that no air comes up with the drug in it, because the particles can and will cause someone to become under the influence of this drug. These are the references that I used to learn about fentanyl today. I hope that we all learned something and that this has been resourceful and helpful. Thank you for listening.